In this lesson, we're going to work on adding and subtracting mixed numbers. Now, when we do this, there are two different approaches we can take. One method of adding and subtracting mixed numbers is based on turning them into improper fractions. Of course, that's the improper fraction method. There is another one that's based on borrowing and carrying over, essentially taking advantage of some skills that you've already seen. Either way, you will get a choice. You can choose to use the improper fraction method, you can choose to use the mixed number method, and it doesn't matter which one you do. So of course, figure out which one you like, then start getting good at that one. For the purposes of this video, we're going to go over both of them and see that we can use either method to accomplish our objectives of actually getting the answers when we add or subtract, and we'll do one example showing that you can use this to calculate perimeter. Now, of course, there are some prerequisite skills. Before you can add and subtract mixed numbers, you have to know how to add and subtract regular fractions. Whether the denominators are alike or different, you have to know how to add and subtract fractions. If you can't, stop now and go learn that particular skill. Also, with the mixed number method, you'll have to know how to carry over and borrow. Now, when you look at textbooks, the most common method that they use to show you how to do this is to say, if you want to add or subtract fractions, turn them into mixed numbers. And we looked how to do that the other day. We saw that you can multiply and then add. 3 times 2 would give you 6. 6 plus 2 equals 8. And so we can get this as 8/3. Similarly, 3 times 1 equals 3. Plus 2 would give you 5. And so our problem can be rewritten with improper fractions, 8/3 plus 5/3. When the denominators are the same, we know that we go across the top. 8 plus 5 would give you 13. And because our denominators match, they stay the same. And so here is our correct answer. They do add up to give you 13/3. But because our problem was originally given to us with mixed numbers, we shouldn't have improper fractions as our answer. We should put it back in the mixed number form. And so this is another piece that we saw how to do with our earlier lesson. We saw that you would have to set up division. 13 divided by 3 would give you 4. And a remainder of 1. Therefore, this answer would be the whole number of 4, a remainder of 1/3. This is the improper fraction method. Most students, when they are first taught how to add and subtract mixed numbers, are shown this method. In large part because when we get into multiplying and dividing, we have to do it this way. We have to get improper fractions for multiplying and dividing, and so they give you additional practice with that skill so that you can use it when you have to do it. I'm not a fan of this method though. I'll admit, the way my brain works, I don't like it this way. I think that this is more work than I want to do. My preferred method is the mixed number method. And this mixed number method is based on taking advantage of some skills that you've already done, things that you already know from elementary school. In particular, if you want to add numbers, for instance, if you wanted to take 17 plus 24, you notice how I put them stacked on top of each other? When you first start learning how to add, you always stack them on top. Well, that's what I'd like to do here as well. Instead of putting them side by side, I'm just going to stack them on top and say, add. And of course, this sets it up so we're taking fraction plus fraction, whole number plus whole number. And so, with our fractions, 2/3 plus another 2/3, that is 4/3. Remembering that When the denominators match, they stay the same. Going to the whole numbers then, 2 plus 1, there's our answer, 3 4/3. This piece is correct, but of course, you'll notice this one has an improper fraction. And we discussed before that whenever you have a mixed number, it's not okay to have an improper fraction inside your mixed number. And so this is something we have to fix. When you have something like this, it's similar to the idea of, if we're looking over at the 17 plus 24 here. Remember when you were adding 7 plus 4 to give you 11? Nobody would put the 11 down and take 1 plus 2 to get 3. It's not 311. When you were learning how to add, remember that there was a rule for carrying over. In particular, when you get to that 11, you would put the 1 down, then you had to carry over to the next position. 1 plus 1 plus 2 would give you 4, and so you had your correct answer of 41. The same way that you had to learn how to carry over with whole numbers, if you're going to take this mixed number method, you have to learn how to carry over with fractions. In order to carry over with a fraction, what you've got to do is our denominator of 3, whatever your bottom number is, you'll subtract that off of the top and carry over a 1. So our answer then, 4 subtract 3, that's 1. 1 plus 3, and you'll notice that answer matches the one that we had before. 4 1/3, matching 4 1/3. You'll get the same answer either way, so it really does not matter which way you want to do it. If you prefer the improper fraction method, for instance, if you've already worked with it a little bit and you feel like you're good at it already, then go ahead and continue developing your skills with something that you kind of know. I like this one a lot more because I think it's shorter, I think it's easier, it's just the way my brain works, it clicks better. Right? We'll go over and do this one with the improper fraction method. Converting them to improper fractions, 5 times 5, 25, 25 plus 1. Okay, so that's 26 over 5, minus 5 times 1 plus 3, that's 8, so 8 over 5. And so now we have to subtract it off and say 26 subtract 8 is 18. And now we have to take 18 over 5. 18 divided by 5 is 3, with a remainder of 3. Therefore, we have the whole number of 3, the remainder of 3, denominator of 5. And we have our correct answer of 3 3/5. The exact same problem done with the mixed number method. We have to take 1 minus 1 3/5. And here we see a problem. We can't take 1 subtract 3. Just like when you were taking something like 21 subtract 13, you couldn't take 1 subtract 3, you had to learn how to borrow. Well, when we borrow, we saw that we could just take off and carry over this 1. A lot of times students will want to take this and borrow and bring over the 1. That's not correct with fractions. Just the bringing over the 1 is a shortcut that's based on having a decimal system. Ones, tens, hundreds, every position in our decimal system represents 10. When you're working with fractions, you'll still borrow off the 5 and put down the 4, but instead of just carrying over a 1, you have to add whatever your denominator is. And so our work then, 1 plus 5 equals 6. 6 subtract 3 is 3. Denominators match. 4 subtract 1 is 3. Done. Same answer, 3 3/5. This is why I prefer the mixed number method. Either way you're doing it, you have to show your work. Because of course, showing your work in math is always the most important thing. I like this method because there's very little writing, and yet I'm still able to show all of my work. There's more writing this way, and that's why I don't like it. They're both fine, they're both good, it's just picking a method that works well with your brain. Alright, you'll notice this problem is a little bit different because these have different denominators. So with our improper fraction method, we know that we can multiply and add to get 13 over 4. Multiply and add to get 5 over 2. And because the denominators don't match, we then have to add these two fractions. And when we went over adding fractions, we saw that there were multiple different ways that we could get this answer as well. One method was based on identifying the least common denominator. For this one, that would be 8 or 4. We can turn 2 into a 4 by multiplying by 2, which would allow us to change our problem, rewriting it in an equivalent form as 13 over 4 plus 10 over 4. I don't know why I wrote 14 there. Okay, continuing that, 13 plus 10 gives you 23. So 23 over 4. Take that off, do our division. 4 will fit inside 23 5 times with a remainder of 3. So we wind up with 5, remainder 3, and 4. We have our answer, 5 3/4. And we can see how much writing it took. Completely valid method, and I want to stress if this is one that you like, go ahead and do it. If we were to take the mixed number method, 2.5, and we still have some scratch work here then, because 1/4 plus 1/2, they're still not the same, so I'm going to come off to the side and say add up these two fractions. Well, because 1/2 is the same thing as 2 over 4, we can add our two fractions. 1 plus 2 would give us 3. So fraction plus fraction, that's 3/4. 3 plus 2 is 5. Done. 5 3/4. And previous method, 5 3/4. Recognizing this is still a new skill, we should continue practicing. We've got a couple more examples. Okay, continuing, this is the improper fraction method. And trying to save a little bit of time with the video because it's already a bit long, I'm going to go through them quickly. 5 times 5 is 25, plus 3 gives us 28 over 5. 1 times 5 is 5, plus 4 is 9. So that's 9 over 5. Because our denominators match, 28 plus 9 equals 37. Needing to set up some long division. This time I'm going to do the long division in my head instead of writing it out. 37 divided by 5. 5 will fit in 7 times with a remainder of 2. There's our answer, 7 2/5. Same problem with the mixed number method. 1 4/5. Add. because the denominators match 5 and 5, we can simply take 3 plus 4 to get 7. 5 plus 1 gives us 6. And because 7 over 5 is an improper fraction, this is one that we need to carry over. So subtract off the denominator, carry over the 1. 7 minus 5 is 2. 1 plus 6 equals 7. And we're done. All right, so continuing with our piece with the improper fraction method, we can multiply and add. 6 times 5 is 30. 30 plus 5 is 35. 3 times 3 is 9. 9 plus 1 would be 10. And so here we have 35 over 6 minus 10 over 3. Just to refresh your memory, we did have another way besides the equivalent fractions method. Besides getting the common denominator, we did have this tool where we could take 35 times 3. That equals 105. And then we could take the other diagonal, 6 times 10. That's 60. 6 times 3 equals 18. And so we could do them this way. 105 minus 60 equals 45. And so we could get our answer with this kind of diagram. Diagonal, diagonal, across.
Oh yeah, I remember doing that.
And remember, of course, that when you use this particular method, it very, very frequently gives you a fraction that you have to simplify at the end. In particular, with 45 and 18, we'd have to recognize that a 9 will go into both of those. And so when we simplify it, we'd wind up getting 5 over 2. That mixed number, or that improper fraction, 5 over 2, we'd have to then turn back into the mixed number, 2 1/2. And there we're done. If you want to use this method of adding fractions when the denominators are different, you can go ahead and do it. The point is, we have options, we have choices for how we want to get things done. Choosing to do this mixed number method is a choice. It's not like this is the only way. I mean, we keep seeing again and again there's multiple ways to do it. In particular, with 5 over 6 minus 1 over 3, if you want to do it with this method, you can. It's completely valid. For these particular problems, though, I think it would be easier to say 5 over 6 minus 1 over 3, and then recognize that if we take and multiply 1/3 with the 2's, 1/3 is the same as 2/6. And so 5 over 6 minus 2/6, that is 3/6. Well, if we think about 3/6, that of course can be simplified. That's just the fraction half. So that tells us then 5 over 6 minus 1 over 3 is the fraction half. Fraction minus fraction gives us half. Whole number minus whole number, 5 minus 3, is 2, and we got our same answer. All right, with this last one, we'll still use the mixed number method. We're not going to do the improper fraction method just to save us a bit of time. But I didn't want to skip over this one just as a reminder. If we're using this method, 1 over 3 subtract 2 over 3, you can't take 1 minus 2. This is a situation where you have to borrow. Remember that to borrow, you'll subtract off, but then you have to add on your denominator. Therefore, we have 1 plus 3, subtract 2, 4 subtract 2 is 2, so we've got 2/3. 3 subtract 1 is 2. And so there's our answer, 2 2/3. The last problem for this video is to show you how this can be done in context. What is the perimeter for this triangle? Well, we know for perimeter, you have to add up all three of your sides. 2.5, 1.5, 3.25. And there are lots and lots of different ways that we could approach this particular problem. We know that we could convert them all to improper fractions and add them up that way. We know that we could get a common denominator for the 2's and the 4's and get to it that way. If we were to get the common denominator, we could recognize that 1/2 is the same thing as 2/4. And so we could simply go through and say 2 plus 2 plus 1, adding those three numerators. That's 5. Adding the whole numbers, 2 plus 1 plus 3. And so we have our answer 6 5/4. But since it's an improper fraction, we have to subtract off and carry over, which gives us 7 1/4 inches. And we're done. Whether you choose to use this mixed number method or you choose to use the improper fraction method, it's entirely up to you. Both methods are valid, both of them are correct. It's just a matter of picking which one that you think is easier. Ultimately, though, whichever method you choose, make sure that you can accomplish the objective. Can you actually add and subtract to get a correct answer simplified in its mixed number format? And would you be able to do that in the context of calculating perimeter or in any other word problem context? As long as you can meet those two objectives, we're good to go.